Hello, everybody. Our speaker is Dr. Margaret Burnett, who's from Oregon State University. Telling you a little bit about it, she's a professor of computer science. She works on end-user programming, which is where I know that her from. We share an interest in the topic. And end-user software engineering, which is, she's going to explain to you what that is and how it's different than end-user programming. And also on gender issues in these contexts, which there are some fascinating ones. So she's the founding project director of the USIS Consortium, which stands for End User Shaping Effective Software, I got that, which is a collaboration among a number of universities and IBM. And she brought with her, because she knew it was such a fascinating topic and she wouldn't be able to answer all the questions, two other distinguished researchers in this area, Alan Blackwell, who's from the University of Cambridge, and Alan Seifer, where you have an excess of Alans today, who is currently at IBM, but you may know his work at Apple, Cocoa, and things like that. So we're going to expect them to join in and make this a lively discussion. Oh my gosh. So, look, you didn't get that free lunch for nothing. You have to work for it. So go ahead, Margaret.
Thank you, Robin. Let's see, is the mic on? It is now. Excellent. Okay, so here I am to talk to you about end-user software engineering, and I'll tell you a little bit about that. But then I'll focus on the part of it that's currently near and dear to my heart, surprise, explain, reward. So I'll tell you about that too. So starting off with, well, what is end-user software engineering and what kind of problem is it trying to solve? The beginning of this isn't a problem. It's just a reality. There's a lot of end-user created software out there in the world. Mostly, it takes the form of spreadsheets, but there are a lot of other forms of it too. Dynamically created web pages, simulations, any manner of things, email filtering, all of these things are created by end users. So they're programming. And what so far is supported is the create phase. So there are many, many ways for end users to create their own programs. Unfortunately, there's a lot of literature that says that errors abound in these programs that end users are creating. And for example, up to 90% of production spreadsheets, those are the ones that people are actually making decisions about, have been reported to be erroneous. There's another problem too, and that is that end users are overconfident about the correctness of the modifications and programs that they create. So there are these big reliability problems. And so end-user software engineering basically is what happens after create. How can we support the rest of the software lifecycle? So we'd like to reduce errors in end-user programs. That's what it's all about. But at the same time, we don't expect end-user programmers to have the motivations or the training or even the interests in software engineering. Because if they did, they probably would have gone into computer science or software engineering careers, not whatever careers they're really in. The research that I'm here to talk to you about today is work that we've done in the context of the USIS Consortium, which Robin mentioned. And as she said, EUSES, USIS, stands for End Users Shaping Effective Software. This is a big consortium of researchers from 7 different institutions: Oregon State, where I'm from, Carnegie Mellon, Drexel, Nebraska, Penn State, Cambridge in the UK, and most recently IBM. So anyway, we're all working together on aspects of the end-user software engineering problem, and that's the context of the research I'll be telling you about today. Here's kind of what areas of space are occupied by end-user software engineering. So there's this traditional software engineering and languages group, and then there's what we might lump together as HCI and psychology, and then there's education. And so the overlaps, the intersections in these bubbles are where end-user software engineering lives. For example, some of my colleagues are looking at sources of faults or errors that end users make when they're creating and modifying their own programs. And that falls over there into this intersection area. Some people are working on ways to do static and dynamic analysis of both the, quote, code that these users are creating, like, for example, the formulas in spreadsheets, and also the data that's getting fed in and out as a way to try to spot errors to help end users prevent or fix the ones that have managed to creep in. The incrementalness and performance and speed of these algorithms is a big deal because of the way we need to communicate with end user programmers. They have environments in which immediate visual feedback is expected, and then they have their own expectations too. So we draw findings not only from what we know from software engineering and languages, but also from education and how you communicate with people that don't necessarily understand the concepts that are behind what you're trying to tell them. And of course, HCI and psychology. I'll be talking to you a little bit about some things that come up in those 3 stars. But the big one that I'm going to talk to you about today is this one. If we build it, will they come? So that's where surprise, explain, reward fits in. If we build something wonderful for end user programmers, how are we ever going to get them to use it as a way to guard against or fix errors that have crept in? So in the previous slide, I used words like static analysis and incremental algorithms and that sort of thing. And when I do that, a lot of times what happens is people's mindsets sort of slip over to the software engineering and computer science world. So I don't want you to forget, don't go there. This isn't for you, it's for them. Okay? So here are 4 end user programmers, for example, a teacher. And that teacher might be using a spreadsheet to keep track of his grades. We have a veterinarian. Perhaps she's building some sort of dynamic web page that helps her manage appointments, or who knows. Or maybe the musician is doing that. Okay, so these are the people we're talking about supporting, even though we don't expect them to have any training or interest in software engineering. And we don't expect them to develop an interest in becoming educated in software engineering either. I'd really rather have that veterinarian studying medical books in her off hours than reading software engineering textbooks. So here's the setting that I'm going to be showing you some of our prototypes in. This is a research prototype of a spreadsheet system called Forms 3, which is something that my students and colleagues and I have built over the years as a vehicle for studying this. All I really want you to note here is that there are these cells lying around, and they're not locked into a grid. So you can notice that. You can notice that they're allowed to have meaningful names like Monday, Tuesday, Wednesday. And you can notice that you can actually see the formula and the data at the same time. So that's what there is to notice there. We'll be using this, this prototype as our way of seeing some examples. OK, so if we build it, will they come? Well, the first thing we have to talk about here is what are we talking about building? So here's a segment on a couple of devices that we've built to support end-user software engineering. The first one is testing, a form of systematic testing aimed at end-user programmers. So first we have to think about, well, all right, so if we're talking about end-user programmers and spreadsheets, then what is testing? Well, we can define a test as a decision that they make, that the output is right given the input. Then if you're familiar with the notions of systematic testing from software engineering, you've probably heard of the term test adequacy criterion. So it takes an infinite number of tests to prove that your program is correct. So we can't expect end users to sit here that long. So we have to figure out some way to know when they've done enough, and that's what test adequacy criteria do. So behind the scenes, we've come up with a test adequacy criterion that our system uses to reason about when enough testing has been done. So the strategy behind this device that we've come up with, which we call WYSIWYT, which stands for what you see is what you test. Excellent. A for Alan. The strategy is to incrementally update what the system knows about testedness according to this formal criterion, allow the user to incrementally inform the system of decisions, and immediately reflect the new testedness in border colors. So here's a little scenario. Initially, the spreadsheet is untested, and there are these red borders, and that indicates that they're untested, and there are little checkboxes there, and little question marks in those checkboxes. Red means untested, and a checkbox is a way to record a decision that that value actually is working out pretty well. And so let's say that we've got our user, and they have noticed that this value is correct. So they check it off. The circle I've drawn here is something I've superimposed. It's not part of the screenshot. I'm just showing you where the check mark is. All right, so this border turned purple, and these other ones turned blue, okay? And so what happened here is they liked that value given the inputs. Blue means tested, so now we know that red means untested and blue means tested. And it turns out that anything in between means something in between. So purple is between blue and red, and therefore it means partly tested. So that's what they've done. But there aren't any more little question marks. So that's really indicating to the user, if they happen to know this, that they can check other things off if they want to, but they're not actually going to be able to increase testedness anymore unless they do something different. And so what they need to do different, actually, is, well, we have this if-then-else formula, and so they really need to exercise some other condition. So they're going to need to change this input, any of these inputs, really. But let's just say they choose this one to change, turn it into a 1, okay? So now we have a new question mark. And this is indicating that if we choose to say that that value is right, we're going to be able to make more testing progress from a systematic perspective. And let's say that that value really is right, so we check it off, and now everything's blue. All right, so that's basically the way WYSIWYT works from a user's perspective. There have been a bunch of empirical studies regarding WYSIWYT, and basically what they tell us is it works really well. Always in these studies, WYSIWYT participants have higher test coverage. They tend to show a functional understanding of what it is they're accomplishing with these check marks and what the border colors basically mean. And they also have an appropriate judgment of how tested the spreadsheet is. And that was the whole motivation behind this. Because we could imagine somebody working on a spreadsheet that they really care about, like let's say their income tax spreadsheet or something like that. And they might test and test and test and think that in fact they've done a great job of testing, find some error near the end of the testing, fix it, and leave with that good warm feeling that the whole thing's been really well tested, when in fact that last fix could have had really far-reaching consequences and they may need to do a bunch more testing. So it was that error that we were trying to guard against, and we've done a fairly reasonable job of doing that. In some other ways, we sometimes get results. Sometimes we find that this also helps them to be faster and more effective at debugging on some kinds of problems, some kinds of bugs, that sort of thing. And we also find less overconfidence about the correctness of their spreadsheets, which is good. So it's worked pretty well for us. Still, keep in mind, in these studies, we always introduced people to WYSIWYT, right? And the theme of this talk is how are we going to get them to even pay attention to it. There's one other device I want to tell you about briefly, assertions for end-user programmers. So assertions are ways of saying things about what you expect of the program. It adds checks and balances that can continually guard the correctness rather than you having to notice and test things as you notice them. So it can't be accomplished via testing. And the nice thing that caused us to think assertions might be a good idea is that they don't have to be all or one. You don't have to commit to designing this whole thing before you ever have anything executable. You can just add 1 or 2, and you still make some progress in having more safeguards in your spreadsheet. And of course, you can add them incrementally as the spreadsheet starts to develop. So here's what they look like. Here's that same spreadsheet we were looking at a minute ago. This thing here is a user assertion. They've typed it in, it's a range. It says that this spreadsheet's allowed to be between 0 and 8. And you can tell the user typed it in because here's a little user picture. This one down here is a system assertion. So the system has figured this out by itself. It said that it thinks that this cell should always be between 0 and 48. And it got that because they entered enough assertions on the cells this depends on to where it was able to propagate those things forward through the formulas to figure out what was implied. Of course, we also have a user assertion. They happen to have also typed this. And we have a conflict between these two. That's what the red circle means. We also have a conflict in that the data value doesn't fulfill both of these. It's outside the range of that top one. So we have an assertion conflict and a value violation. And so what we hope is that these red circles, or perhaps just the system assertion not looking right, will somehow alert them to the fact there's got to be an error here, because there could only be one of 2 things wrong here. Either the formula is wrong, or there's a wrong assertion, okay? And in fact, when we did this in a study, exactly what one of our users said was, there's got to be something wrong with the formula. Good user, that's exactly what the situation was. So that's the way assertions work. All right then. So how can we get end users interested? Surprise, explain, reward. That's the strategy that we've developed to do this. Let's not forget who it is we're talking about, people who aren't necessarily interested in software per se. They're just trying to get something else done. So the usual computer scientist view is if we build it, they will come. Okay? But why should they? So our surprise, explain, reward strategy has been long influenced by this model of attention investment, which actually we have the creator of right here in the audience. That's Alan Blackwell's model. And it models the way people make decisions about what kinds of features in software to make use of, how to spend their time. Because let's face it, they have plenty of options for how to spend their time. So they're trying to be as productive as they can. So they have to think about the cost of the new feature. So how many of you have ever used a spreadsheet? Raise your hand. Okay, leave it up there if you've used pivot tables. Okay, we see only 2 hands now. What about the rest of you? Are you deficient? What's wrong with you? That feature's been in Excel for years. All right, so you probably haven't used that feature because you don't use absolutely everything. Why not? It's not a good use of your time to figure out how to use absolutely every feature. So how do you decide which features to try out? Well, you think about perhaps the cost of the new feature. According to the model of attention investment, that's exactly what you do. Not only the cost of actually making use of it on a day-to-day basis, but the initial cost of learning it and even figuring out what it's supposed to do. You weigh that against the benefit of the new feature. How many of you know what would be good about pivot tables? Well, hopefully, okay, so there's one person who didn't claim to be a user of them, who knows what would be good about them, but the rest of you don't know. So how are you going to make this cost-benefit decision if you don't even know what the benefits are, right? Very difficult. And then, furthermore, there are the risks. There are the risks that the benefits won't really pan out, or even worse, that you put the system into a worse state than it was in at the beginning, and now you don't know how to get out of it. So, okay, so this forms the basis of much of our own set of design decisions in the surprise, explain, reward strategy. So how are we going to interest them? What our key was to try to arouse their curiosity. So psychology researchers tell us, and empirical studies of programmers agree, that end users, programmers alike, pretty much believe their programs work. Things they create work. This is what they believe. And therefore, they have all the information they require. They don't need to go exploring new features. Research in curiosity also suggests that showing them the presence of an information gap, something that they don't actually know, makes them curious. So for example, suppose you're walking down the street. You think you know everything that's required to know about walking. So you're probably not thinking about walking. First I put my foot down, then I put my other foot down. You don't do this, right? You're thinking about something else. But then suppose you trip. All right, so this has revealed that there's an information gap, that in fact, you really don't know everything that you need to know about walking, at least not down this street. So what do you do next? You probably look down. So surprise showed them the presence of an information gap to arouse curiosity. According to this theory, when the presence of an information gap is revealed, users will examine the object that introduced this information gap in order to find out what's going on. You look down because that's where the gap was. You didn't pull down a help system up here, okay? Down at the feet where you tripped. Now, this is an example of self-directed learning. And self-directed learning is a very important attribute of our surprise, explain, reward strategy. So surprise's job is to deliver to explain, to get them to seek explanations. Explain's job is to deliver them to the rewards, to number one, make clear what the rewards might be for doing what we want them to do, and number two, tell them what we want them to do. Then, yeah, okay? So let's see here. So there are 2 settings for surprises. One of them isn't on this slide, so I'll just mention it briefly. So if you just kind of scroll back in your mind to one of those pictures of Forms 3 that I showed you, the spreadsheet environment, there were these red borders. Okay? So if you fire up your spreadsheet and you see red borders around a few cells, you might say, I wonder why those are there. You know, I never fired up spreadsheets before that had red borders, so that's a surprise. Okay? And you might seek an explanation eventually for why that's there. But that's not the example I'm going to tell you about today. Supposing you've gotten that far. Okay? You already know what the red borders are, and you know how to use WYSIWYG to the extent that I showed you, with the check boxes and the border colors. Now, what we've found, coming to the slide here, is that subjects find that easy at first and accessible, and they are into it. But eventually, it gets hard, because eventually, you've covered all the situations there on your spreadsheet with the data you've got, and you're going to have to conjure up different data to try to test the rest of it. Otherwise, you won't be able to make testing progress. You won't be able to turn the rest of the cells blue. And it becomes harder and harder and harder to conjure up suitable values to be able to cover all that. And so if you've done your own testing, you know this to be true. And so eventually, our users often get stuck. And we have this feature called Help Me Test that they can push that will then conjure up new input values for them to help them have an opportunity to get more coverage. And we've tested this in the lab before, and people like it. They like Help Me Test, and they use it more than once. We've taught them how to do this, and they use it more than once. So this is a good opportunity for surprises, and we can take off from here to try to get them interested in assertions. So what we've done is when they ask Help Me Test to give them some values, they're waiting for an answer. They've started a conversation, okay? And so they're expectantly waiting for something good, and they get it. They get the new values, but they get something more, too. They get assertions. So here's how it works. When they do a Help Me Test, the system changes the values in cells and darkens up the ones it's changed to whatever it thinks is suitable. And then it also gives them this other thing that they didn't even ask for, these assertions that the system has guessed. They've never seen them, okay? And so what they may say is, what the heck are these? This is an information gap. I didn't know about these before. Maybe they'll just ignore them. That's okay, too. Now, these assertions actually are pretty bad. This one, it was a payroll application, you may recall, when I had the spreadsheet up there. And so this was supposed to be the hours worked on Monday. And the assertion is guessing that between -1 to 0 would be a great example, a great range for the number of hours people worked on Monday, which is patently ridiculous. And this one is guessing 0 to 5. So these are bad guesses, and this badness of the guesses may be an important part of attracting their interest and saying, what? -1 to 0? What are they, nuts? There's a second surprise that happens. While Help Me Test is trying to conjure up suitable test values, remember this is what they asked for, it's also thinking. And it's thinking about assertions as well as about these possible test values. And so it's kind of guessing, kind of changing the assertions as it's coming up with suitable test values. And sometimes those will violate the assertions it's guessed. And then you'll see little red circles kind of coming and going as it's thinking. And keep in mind, the user isn't trying to do something else at that point. They've started a conversation. They're waiting for an answer. Even so, all of this feedback is passive. The system isn't going to do that if they haven't asked it to do something for them. It's trying to win their attention, but it's not actually requiring it. Empirically, we've found that users go several minutes before they act on this feedback. And we're going to return to this issue later. Finally, the explanation. Okay, so we've talked about the surprises. Surprises are supposed to deliver them to explain. So they've seen these assertions. And what they might do is hover over it in order to get a tooltip. And here's our tooltip, a little longer than your normal tooltip. First, it says the computer's testing caused it to wonder if this would be a good guard. So this is the semantics of what they're looking at. It says, fix the guard to protect against bad values. This is the reward, okay? As well as what we want them to do, which is to fix it, okay? And we give them enough information to succeed at that action by typing a range or double-clicking, okay? So that is the charge of all of our explanations, is to cover that much ground and to be short. The reason that we chose to deliver explanations through tooltips is because, as I mentioned, users seek explanations from the object that surprised them, not somewhere else. The reason that we suggested in action is that our explanation system is heavily inspired by the work on minimalist learning that Jack Carroll and Mary Beth Rawson have done over the years. And many of the principles that they put forth are that a way to get people to learn stuff is to get them to take action and do it. And that furthermore, users are very active and very engaged in the tasks they're trying to do, and that using that as a setting to learn about things is often the way they want to proceed. And of course, why we're talking about the reward comes back to the attention investment model, that without making the rewards clear of going down a certain path, then people have no way to make informed judgments about how to weigh the costs and the benefits if they don't even know what the benefits are. Okay, so what are these rewards? Well, if we're lucky, a red circle around a value will indicate either bugs or incorrect assertions. These rewards are good in a short-term perspective when they're first learning. Oh, good, I got a red circle. You know, I can hover over that. And it looks like I'm doing something right. And then it's also a good reward in the long term, because this is your way of the system automatically spotting errors for you. Help Me Test also behaves better when this happens. It's not necessarily obvious to the user, but Help Me Test, once we have these assertions up there, it tries to honor them for the inputs so that it picks better inputs. And it also tries to break them for the intermediate ones, so that it's actively trying to find your bugs for you, trying to find contradictions. Also, the computer-generated assertions might look wrong. That was an example I showed you earlier. This thing, 0 to 48, didn't look right for the total number of hours for a week. Should have been 0 to 40, like what they said. Red circles around conflicting assertions are, of course, first surprises and then become rewards. They found the errors. We did a study. This was a bunch of business majors at our university who were familiar with spreadsheets. They had no assertions experience. We did not give them any experience with assertions during our setup of the tutorial. In fact, we never mentioned them at all. So all they had was surprise, explain, reward. And what we wondered is whether that would succeed at enticing them to use assertions. And we found that surprises of the sort I've described to you did get their attention eventually. 94% of our users did use assertions at least once. The average time before they started using assertions in task 1 was 13 minutes. But once they discovered assertions, they got religion, and 87% of them kept using them. The mean was 18 assertions per user, and by the time they got to task 2, the time to starting using assertions was 4 minutes in. And we were counterbalancing what was task 1 and task 2, so yeah. At first, they did enter assertions using Help Me Test. So Help Me Test would have these guessed assertions and they would edit them. But eventually, they would just take initiative and do it themselves. So they'd just enter them on in. So Help Me Test trained them, but then was not really necessary for them to continue using them. The rewards seemed to be sufficient because they kept using them. Once they used them once, they used them again. In fact, over half of them actually used them within the first minute of task 2. And they said things like this: I found them reassuring because I think they help with accuracy. This was in a post-session interview, actually questionnaire. And the other one noticed that reward that wasn't so obvious. They said, well, I use them to try to get the help feature to work better, to stay within my limits. Okay, so we could be drilling down into surprise or explain or reward or all three of them. But I kind of suspected that 75 slides or whatever wasn't going to fit in this period of time. So I picked the one that I'm the most into right now, which is explain. So we're going to dig down into explain and see how far we get. And after we do explain, we'll see if we still have time to drill down into surprise some more. So one of the things that happened with surprise, explain, reward is we thought, wow, this is great. This works wonderfully. And we were using it on lots of users, trying to study some other things about them. And we found that sometimes our users continued to get muddled and confused. And so we asked at some point, well, didn't the tooltips help you? And they said, well, yeah, they were helpful, but they just didn't tell me what I wanted to know. And so we said, duh, wouldn't it be nice if we knew what they wanted to know? So we did a study to try to find out what end users want to know when debugging. And so our experiment was a pair think aloud, which worked out really well. We recruited pairs who did not have any computer science experience, who knew each other from the beginning, so we didn't have to worry about a warm-up period and that sort of thing. And we gave them pretty much nothing except each other. So the instructor gave them some very basic instruction about just how you cope with Forms 3. We gave them a couple of spreadsheets that had bugs. There were no tooltips, almost no instruction. The instructor was not even available to them. The instructor went into another room and said, you know, if you have any problems, you can contact me over IM. Okay, so yeah, they were available, but that's kind of high cost to start having to type in stuff, so people didn't use it very much, which is what we wanted. So they had only each other. And then what we did was a content analysis of their words to see what they wanted to know. So up here in the corner is a little graph with 5 lines. And these lines you don't have to actually read. It's just a way of walking through the next part of the presentation. We're going to talk about 5 kinds of information gaps. And the first one, Oracle specification, was the most prevalent. And so we're going to work our way down. So this is about whether the values they're looking at are right, or whether the formulas they're looking at are right? So the Oracle problem is whether you can tell whether your output is right, and specifications are specifications. So here's an example, one subject saying, divided by 10? I don't know. I guess it should be times 10, talking about the specification. These gaps were not centered on features, okay? 40% of the gaps were of this nature. The users were focused on the tasks, not the environment and its features. So its implications are, first of all, we need more research into supporting this kind of information gap. Because you look at it and you say, well, yeah, of course they're talking about the task. And yet, when you think about what problem solving is out there, very little of the help that's available, especially within the system, is about this, okay? So that's one of the implications. Another implication is it's very consistent with what Jack Carroll and Mary Beth Rawson have always been saying about the active user, the user that wants to stay engaged in their task, not go off and learn something else. So that was the most prevalent, 40%. The next most prevalent, 30%, was about strategy. What should we do now was one example. Another example was, let's type it in, see what happens. Okay? So they are, and much of what they were doing, 22% of that 30%, or let's put it another way, roughly 2/3 of that, were strategy hypotheses, like that second one, proposing a strategy to follow. Note that these two are not about features, okay? So many of these were global in nature, and there's no real feature or object even to tie that kind of help to. The third most prevalent was features, but it was only 16% of the gaps that were expressed by these people. Remember, we gave them no instruction, okay? They had only each other. And yet, most of the time, what they weren't talking about was features. But here's one where they were. So with the border, does purple mean it's straight up right and blue means it's not right? Okay, question about the features there. Now, this type of information can work well with the tooltips. And this is the kind of thing that if we had the tooltips in there, would have probably done a pretty good job at answering that. But as I said, it only accounted for 16% of the gaps. An implication then is that focusing on this type of information would address only a small fraction of what our participants wanted to know. Yes?
It seems to me you switched gears there. That here you talk about features of your tool.
Yeah.
Everything else was about the spreadsheet, the problem tried to solve, right?
Right.
Did you also group in here where people had issues about how the pivot table works, a feature of the tool, of the system rather than your tool?
Okay, so the question for those of you who didn't hear it was that this particular question is kind of focused on the way our tool works. And the question was, did we also look at how other tools worked as part of this? In that setting, there were no other tools. There were no pivot tables or whatever. But what we have found is similar findings to this in a study we did in Excel. So the percentages will be different, though, depending on how complex the feature set and the environment are. But the really important takeaway is we can be saying this is a big fraction, or we can be saying it's a small fraction, but we can still tell it's a fraction. And there are all these other things that people are talking about, too. A very interesting one was self-judgment. Almost close to 10%. It was 9% of the information gaps. They were talking about themselves, not about the system, not about the task, but about themselves. They were judging themselves. They were saying things like, I'm not even sure if we're qualified, to do this problem, right? Talking about us. So these are instances of metacognition where they're thinking about their thinking. And metacognition has been shown to be a very important factor in learning. And so if what we're trying to do is get them to learn how to use these features, engage in end-user software engineering stuff, then this matters. It also ties to self-efficacy, which is a form of self-confidence. And there's a long background in self-efficacy theory that shows that it often can be a predictor of success. And so if there is something that we can do to make their ability to self-judge more accurate, we can potentially improve their debugging persistence, for example, because this is what self-efficacy theory suggests. So this was 9% of the information gaps. So improving the accuracy of self-judgments in terms of how well they're doing may in turn increase debugging effectiveness, is the implication of this one. Finally, there were the big gaps. Here's an example. Whoa, is what one subject said. And another subject said, help, in just about that tone of voice. So we called these big. Sometimes the users aren't even able to voice a specific question. 5% of the total were like this. And one of the implications we found when we really analyzed how these fell out along the timeline was that sometimes the timing of these things, you can tell what kind they are. So if they've just gotten a load of new information and then they just hit a help button, okay, that might be the moment for the system to guess, you know what, I think this is a big information gap. And then hopefully do something appropriate. Maybe even figure out what the cause of confusion is based on what kind of feedback just materialized. Okay, so here are the implications then and opportunities. First of all, information gaps should not primarily focus explanations on features. The user's greatest need in this study was about Oracle and specification problems. Strategy issues in this study outnumbered features 2 to 1 and needs both global and local support. And the accuracy of user self-judgments may impact effectiveness. So we've started working on this. Now, what I'm going to tell you now is very immature emerging research. So, it's not all that far along, and we welcome comments. So what we did is we drew from the above results. We drew from various education theories. We drew heavily from self-efficacy theory and from Schneiderman and Becker's research into how to do video demonstrations. And so what we came up with was a trio of explanation devices. So we still have the tooltips, which are focused on the features and feedback and rewards. But in addition, they have links to strategy videos, videos whose whole purpose for being, well, really have two purposes for being. One of them is to support strategy, and the other is to support self-judgments. They're not trying to be anything else. They're not trying to be about features, because we have the tooltips for that. They're just trying to be about those two things. There is also a textual version of those videos in sort of shorter form. Let me show you what those look like. Forgot to tell you about that bit. Right, so here's the tooltip. 60% of this cell has been tested, so it still needs more testing. And then there's a show me button that leads to the video explanation of strategy if they want to know more that has to do with testing. Wonder what that would be good for or whatever. Here's the text version. So this would be leading to the video on testing. Instead, what they could do is select how can I test my spreadsheet, and then they could either hit show me or tell me, depending on whether they want a video or text. That's a side panel that they can do. Here's what the prototype looks like right now. Here in this corner, these are two of my students, Niraja and Jared, and they are talking to each other about how to, I don't remember which one this is, maybe it's test this spreadsheet. And so they're working together through the problem. These videos, there are several of them. Each one is somewhere between 1 and 2 minutes. And so it's very focused on exactly, whatever strategy they're trying to import. There are a couple of things that are going on here. The headshot, okay? So you might wonder, well, what's that there for? That's there for the self-judgment thing. So one of the things that self-efficacy theory tells us is that people who see someone they can identify with succeeding at a problem may have their own self-judgment increase if they say, oh, yeah, I could do that. I see that person doing that, and I could do that. So that's why they're there. And then, of course, the spreadsheet is there, so you can actually see what's happening. Here's the textual version. So what happened, the videos were scripted. This takes word for word off the scripts, okay? But of course, what the textual version does not have is the example, so it's shorter. What it does have is hyperlinks, so you have sort of a random access thing. You can get around from one to the other quite readily. So it has advantages and disadvantages, but you can see that roughly the content is the same. So we just finished doing an empirical study. We haven't even managed to get it out yet. So here's just a little sneak preview of what we've found. This approach closed roughly half of the new gaps in our new study of these three types. Strategy, which the videos were after. Oracle specification, which the videos weren't after. But yet, it seems that the help with the strategy may well have helped with the task performance as well, which is, a very nice outcome. And self-judgment. Interestingly, the video versus the text form met different sorts of enthusiasms. It depended on what the users were doing. So when they were first learning a task, when they first decided they needed to know something about how should we test, they were slightly more likely to go with the text form. Now, I can explain this from an attention investment standpoint if I want to, because it seems shorter. But in fact, it wasn't an overwhelming difference, text versus video. So a lot of it depends on kind of what their own judgment was about how much information they wanted, what kind of learners they are, that sort of thing. Then, when they went back to an explanation of the same topic, oftentimes they would switch to video. And so that was slightly more prevalent. And so you can imagine, okay, they saw the thing one time, and now they're realizing, gee, this is kind of tough. And the video has more content to it because you do have that example to look at the same time. So that could be an explanation for that. On the other hand, other times you just want to go back for a quick refresh, and then the text would be better because it's more of a sort of direct access kind of thing. And in fact, in the interview later, they were talking a lot about making decisions based on how long it would take. So this attention investment thing definitely was coming through again. Also, the males and the females seem to respond very differently to the videos. For example, remember that picture of Jared and Niraj? We've seen this in several of our pilots as well as this final study. You can tell actually what they're looking at. You can tell by their head position. We videoed the subjects. You don't really need eye tracking for this. And the females seem to look a lot at the heads, the talking heads, back and forth between the talking heads and the spreadsheet. The males seem to mostly look at the spreadsheet. Every once in a while, one of the two instructors will do something kind of strange, and you'll see their head go, oh. But mostly what they're doing is looking at the spreadsheet. The females smile and nod at the speakers in the video. They're engaged with them. They're communicating with them, especially Niraj. The females are nodding and smiling when she overcomes some obstacle, and they're just into it. The males, well, some of them don't really want you to notice they even need videos. We saw one of our subjects. It was the funniest darn thing. We talked to him about it later. It was a pilot subject, so he was an intern with us for the summer. We convinced him to watch one of these things, and he said, I don't need to watch them. I'm not really a video kind of person. You got to watch it. Oh, all right, fine. And he sits in his chair as far away from the darn thing as he can get, and he leans back, distancing himself. And then finally, later, we told him he did that. And he, I did not. Oh, yeah, he did. And there was another one where, it's like, I hope nobody sees me watching this. I mean, it was really interesting. So the bottom line here is having both forms really, really mattered. Okay, we don't have time to talk about a closer look at surprise, unfortunately. So I think what I'm going to try to do is just skip to my conclusionary slide. Oh, for heaven's sakes. That looks good. Conclusion. No, is that the wrong one? Yeah, this is the right one. No, it's the wrong one. Never mind. Let's see, one more time. Okay, let's see here. It's supposed to be, well, all right. This is not the right conclusion, and I can't seem to get to the right place, so we'll just stop here. Do we have questions?
We are being videoed, so
Repeat the questions.
any questions?
Yes, Alan?
I've got one that I hadn't noticed before, and I might be confused, but I don't think so. So I'm going to push a little more on that previous point. And that is this distinction between learning about using your tool and the distinction about learning whether the spreadsheet is correct or not.
Mm-hmm.
And I had the feeling that when you were doing surprise, explain, and reward, that you kind of confused those two at certain points. And sometimes you were talking about the learning that they were trying to get was learning how to use a tool, and the other time the learning was learning whether they should trust their spreadsheet or not, whether this particular spreadsheet was working. So,
Okay,
is that
yeah,
right?
it's a great question. Let's see here. The short answer is that's deliberate. What happened at the beginning is at first we really thought that it was all about explaining the tool. And that tended to put blinders on us about what things were really possible from our strategy, our explanations. Because if all we aspire to do is teach them how to, think with this feature or that feature, we're not really accomplishing the goal, which is to figure out how to genuinely engage them in software engineering behavior as end-user programmers. And that's really what we're trying to do. And so at first, when we were doing our content analysis of what they said, at first the Oracle specification stuff, we kind of pushed over in a corner and say, oh, that doesn't count, because a help system can't really help with that. And then we said, hold on a minute, we're thinking inside the box here. We don't really care what is possible for us to implement. What we care about is what do they want to know. And once we really started thinking about that, we started to realize the possibilities that an explanation system could really do to have as its goal engagement rather than feature set. So ultimately, I wouldn't call it confusing, or I wouldn't say that we confused it. I'd say we included it because we felt that it was the more worthy goal. Yeah. More questions? Okay, well.
All right, well, thank you all for coming in. Thank you, Margaret.